Hello, in this video we're going to talk about the vector cross product and properties. Now in this video we're not going to prove it. I'll save that for a later video. So I'm just going to define it, and I'm going to tell you how we calculate calculate the cross product of two vectors, right? When we do the cross product of vectors, there are three-dimensional vectors. So if you're given vector u, use of 1 I, use of 2 j, use of 3 k, and vector v, v sub 1 I, v sub 2 j, and v sub 3 k, in the linear combination form. The vector cross product of u and v is calculated when our notation like this. We don't write this as multiplication. It's not multiplication. We say u cross product v, and then you take components u2 times v3 minus u3 v2. That's I, so this will be some scalar amount right here, and then you take u3 v1 minus u1 v3 j, and this would be some scalar amount, and then use 1 v2 minus use 2 v1 in this case. So you're going to end up with another vector. So that's kind of the important part. When we did the dot products, we always came up with a scalar, right? Some number. But when we do the cross product, we're going to come up with another vector, and it does turn out to come out something interesting. And we'll go over that later. And it ends up being, I'll just tell you now, and we'll go over why that happens. If you have two vectors in space, UV, right here, the cross product UV ends up being what we call the normal vector, right? So there'd be a plane here that is created by U and V, and this becomes the normal vector, right? Now, this calculation right here might seem really confusing, but there's actually a pretty simple way that we can do it. But I'll have to introduce you something where I won't prove what it is, but it's really easy to do. It's something called the determinant of a 2 by 2 matrix. So if you take the determinant of a matrix that looks like this, A, B, C, D. Now we don't really need to use the determinant. I'm just using it for the sake of being able to calculate this easier in HL math. But if we take the determinant of a 2 by 2 matrix, all we do is we go like this: A times D plus B times C. That's what the determinant means, right? So it's like multiplying these two and multiplying these two. Sound good? So I'm going to use that for this. Now, the way this looks really confusing trying to figure out how to multiply it in this form. So that's why I wanted to go over how we set this up. And now what we do is we set up this U cross product V is set up by a 3 by 3 matrix, right? Where we're going to have I up here, J, and then K. And then what goes here, we're going to put in the components of U. So use of 1, use of 2, use of 3, and then the components of V down here, V sub 1, V sub 2, V sub 3. Good? And this can be, when you do the cross product of this, it's like we could split this up into 3 different ways, right? So the way that we can split this up is I usually put my hand right over the I, and then I'll do the determinant, right? The determinant of use 2, use 3, base 1, base 2, base 3, right? And then I'll put an I here, it'll be multiplied by I. Plus, minus, the middle one will be minus, and then I'll put my hand over this column right here. So it'll be I'm going to do the determinant of use 1, use 3, and base 1, base 3. And then I'll put J. There will be a negative here. We're going to see how, when I calculate this out using the determinant, how this equals this. And then the last one is plus K. Well, I'll put K at the end. Okay, will come right here. But what goes in this matrix, it's like holding this over here, and I have this one here. So it's use 1, use 2, and then base 1, base 2. Good. Now, using what I've discovered here, the determinant, let's do this. That would be U2 V1. So this would be equal to U2 V3 minus U3 V2, right? And you can see it's turning out to be the same, right? I minus U3 V1 minus U1 v3, and that's going to be j. And they're switched around, right? But, you know, since this is the minus, this would, if you would distribute through, these could switch around too, so you can see these come out to the same. And then finally, the last one here is going to be use 1, use 2. Use 1 v2, I should say, u1 v2, minus u2 v1, right? And that's k, right? And you can see that turns out to be the same. And I moved over a little bit, so there you go. Now I'm going to use this right here, and this is how I usually think about it, right? And I don't actually write this out. I'll go like this. When I have actual numbers here, I'll hold over here. I'll go that times that minus that times that, and that'll give me that component. Then I'll put my hand over this like this, right here, and I'll go. We'll see an example in a second. This times this times this times this, but I'll take its opposite. This times this minus this times this, but then I got to take its opposite because there's a negative here. Then the last one is that times that minus that times that, and then I'll have my last component there. So, so we're going to go ahead and see a problem using that. So let's look at example 35, right? So I'll go 35. I'll set it up. I want to find, it tells me u is 2, negative 1, 1, and b is 1, 2, 5, and then I'm going to find the cross product. So I'm going to go u cross product v, and I'll set it up like the way that I wrote it, and it'll be I, j, k, so it makes it easy for me to do. And then I'll put my components 2, negative 1, 1, and then the components 1, 2, 5, right? And then I'll do what I said I did before. I'll cover this up. This times this is a negative 5. This times this is a negative 2, and that'll be my I. Plus, put my hand over it this way, and then I'll have 2 times 5, which is, almost forgot, this is going to be a minus. Remember, that has to be a minus. Also, you could make this plus, but instead of going this times this, you could switch to this times this, and I'd get the same thing. But I'm used to using the negative. You can choose to do it that way if you like. So it's 5 times 2 is 10, minus 1, right? And that'll be j. And then my last one is going to be this one. That one I go the proper way, which is 4. Minus a negative 1 is plus 1. Okay, right? Sound good? And then what do I get as a final answer? I'll get negative 7i. This would be minus 9j, and this would be plus 5k. We'll get another vector this time in space. And like we said, it does turn out to be the normal, but we'll see more of that in the future. So let's go ahead and you can also do the cross product in the calculator if you'd like. So if I were to do the calculator right here, and right up here is my vectors. Good. And I can go one way to do it, I could go like this. I can, if I want to make a vector u, so I'll go vector u, and I want to store it as a vector, and it's 2, negative 1k. I can say menu 7 vector, and then I can go create. I want to create a vector, and I can make a matrix. And then I only want 1 column, and then there's 3 entries, right? And I can make a vector like this. And then I can do 2, negative 1, and then 1, right? Good. So now I've got it stored as a vector, and then I can make the other vector v, and I'm going to store that as menu. Let's do 7, create matrix. Actually, I could have, so 1 row, right? Oop, my bad. Well, I can make it another way, right? I can go down here. I can go ahead and use these blue symbols right here. So I can go control this way, and then I can say my vector is 1, comma. When I do it this way, I got to put a comma, 2, comma, and then 5, and it will make that vector. And then if I want to do the cross product, there's a couple ways I can do it. The first way, I can go menu 7. I can go to the next one, vector C, go over, and you can see there's the cross product. Just like we could do the dot product here, we could do the cross product here. And then I'll go u comma v. U comma v. end up with the same vector that I had, right? -7, -9, 5. And there you go, guys. Thanks.